in our next example, we will cover the basics of pattern matching and of course of positioning and dimension measurements. So these three functions provide a good basis for a lot of industry machine vision applications. So first thing we want to do is look at the set at hand. So this is a set of images of metallic car plates used in automobile industry, and here is the whole set of 10 images. And our task for this example will be to check if these plates are to pass or to fail our test, and the test is to check if this radius of this hole right here and this radius of this hole right here, if they are in the specified range. So if the holes are of the right size, and to check if these two holes are of the appropriate distance. So first thing we want to do is provide ourselves with some sort of a coordinate system that we will be able to anchor in every single one of our images. So in order to do that, first we need to do a pattern matching function. So you can find it in the machine vision palette. So let's click here and let's open the pattern matching function. When you open the pattern matching function, first thing that pops up is the template editor, NeVision template editor, where you can select the template region for your image. So in our case, let's select this part of the image here. So as it is assumed, this part of the image right here does not change. So let's select this right here, and that will be our template, and we need to provide ourselves with our coordinate system. So this will be the coordinate system for our template, and let's click finish. You could change the position of this coordinate system right here, but we will not be doing that. So let's click finish, and of course you need to save your template. So let's do that, and let's call it the template 1. Okay, so that would be good enough. And of course in the options you can set once again the minimum match score for our pattern matching algorithm. So the values that provide the score that is higher than 800 will be considered a pass, and if the score in an image is always less than 800, then the pattern matching algorithm will return a fail. So in the specifications, you can check right here if you want to search for the rotated patterns or not, and the default setting is so the rotated is checked, and here it says the -5 and +5 degrees of rotation. But in our images, as we have already seen, our images are rotated way more than that. So we will have to put in here the -180 and +180 degrees, and we will not be changing anything else. So we only want to find one match. Let's click OK right here. And the next step would be to anchor a coordinate system with the pattern matching function. So in order to do that, let's click Set Coordinate System, and here you have the origin already specified. So the only function that you have used that returns some sort of a coordinate system is the pattern matching function. So in the Set Coordinate System setup, this will automatically be selected. So For our coordinate system, you can specify if it will have only horizontal motion or only vertical motion, or possibly both. But as we already mentioned in our images are also rotated, so we need to add in the angular motion, and that would be it. So let's click OK right here. So we already did half of our job. The next step would be to detect the edges of these circles right here in an image. And in order to do that, let's find a function that finds the edges of circular regions. So in order to do that, let's choose the find circular edge function that locates a circular edge in a region of interest. So let's click here, and let's leave this auto setup checked. So it will have specified the direction of the edge, so outside to inside or the other way around, and the edge polarity. So dark to bright or bright to dark, you can specify that. We'll leave it at the all edges and look for the first edge. In advanced options, of course, you see the other specifications like the edge points found and their characteristics. And in results, you get the results of the resulting edge that the algorithm found. So in settings, let's, for example, leave this auto setup checked. Let's click OK, and let's run this for our images. So let's see if we will detect all of the edges that could be found in this in our image set. So as you can see in the second image already there is a problem, so it did not find an edge. So let's click here to see what happened. In the auto setup for our first image, the minimum edge strength was set to the 53. So in all of the other images it will stay it will still have the value of 53. So in order to detect the edges in our other images, we need to lower this, and let's try, for example, a minimum edge strength of 25. So here it is. This is the line that represents the minimum edge strength, and as you can see, now the edge is found. So let's leave it at that. Okay, another thing, so let's return to our first image. Another thing you want to do is find this circular edge also. So let's click once again to this function, and so it found the same circle once again, but we do not want to find that circle once again. We want to move this to make it find the other hole. So in order to do that properly, let's stretch this a bit, and the next thing we want to do once again is uncheck the auto setup and click, for example, 25 right here in order to lower the minimum edge strength. Okay, so let's check if this works for all of our images. So here you can click to run the algorithm for different images. It found the edges right up until now. It works fine. Okay. It works fine. Once again. So, as it seems, it works quite well. The next step in our algorithm is to calculate the distance between the centers of these circles. In order to do that, we need to find a function that will enable us to make a measurement between the points in an image. So in order to do that, we chose the caliper function, and here you can specify which points in your image are of relevance, and between which points do you want to make your measurement. So you can here make a change in the geometric feature. So here you can find the distance, of course, and let's click measure to find the distance in pixels, of course, between the center of the first and the second circular edge region. So let's click OK, and that would indeed be it. The only thing left for us to do is to select controls for our VI. So we need to select the outputs of our Vision Assistant Express VI. So the outputs that we do need are, for starters, the fitted circle of the find circular edge function, of course the fitted circle of the find circular edge 2 function for our second circle in order to extract the information of their radii, and we need to check this box right here in order to get our caliper results that are displayed in pixel values. So let's click Finish. Here it is, our Vision Assistant Express VI that is placed in a bit modified interface program that we have already used. So here we specify the memory locations for our original and processed image. Here we provide the image file path to the function that opens our image, and the original image goes to the Vision Assistant, and the Vision Assistant is returning the processed image. So what we want to do is we want to check if if our image satisfies the conditions that are set. So the conditions that are set are, for example, for the first fitted circle, the condition is that its radius is supposed to be in the interval of 49 to 51 pixels. For the second circle, the condition is that its radius is supposed to be between 32 and 34 pixels. And for our last functions, if you remember, our last functions was the caliper function, and that function is supposed to return the distance between the centers of our circles in pixel values. So the condition for that function is to return the value between 510 and 514 pixels. So we have some indicators placed here, and here is a logical operator, and that will only return the true value if all of these conditions are satisfied. And if they are satisfied, we will go into the true case where we will be needing the function that is called the IMAC overlay text. So this function will enable us to write the text on our image, on our resulting image, and the resulting image will say pass if the conditions are satisfied, and it will say fail if the conditions weren't met. So these are the true and false cases. And in the end, here is our image display for our processed image. And for our event structure, the rest of the cases are the same as before. So let's see if our VI is doing what we want it to do. Let's click Run, and let's choose the file path to the first of our 10 images. Let's click OK. And as you can see, here, this function returns a pass. The radius of the first circle is in bounds, the radius of the second too, and the distance between the centers of those circles is indeed in specified bounds. So let's change our image to the next one. This one also returns a pass with these parameters. Let's see what happens for the third one that is rotated. So it's still a pass, even though it's rotated, it found all of the necessary data. The fourth one, let's see the fourth one, it is also rotated and it still returns a pass, the values meet. And the fifth one, will, oh, so this one will return the fail result. Why? Because as you can see, the radius of the first circle is out of bounds, so it's 53.8 pixels, and we specified that it shouldn't cross the 51 limit. So that would be the fail for the fifth one. Let's see what happens for the sixth one. It's a pass. For the seventh one, it's still a pass. For the eighth one, returns the fail, and it returns the fail, as you can see, because neither the distance between the circles is right, and the radius of the second circle is also not in the specified limits, so it's most definitely a fail. And let's see what happens for the ninth one. It's also a fail, but as you can see, the radii are all right. The thing that is wrong is the distance between the circles, the holes, and for the 10th one, it will return a pass. So that would be it for this example.